now 37% of all the students on this campus are biology majors. Biology is a very exciting area right now. The biology that we have here for an undergrad program is different than it is on other campuses. When we came here, the faculty had a blank slate. We didn't have the legacy curricula that you do on other campuses. And so we were able to look at what does a biology graduate in the 21st century need to know? How should that biology graduate be taught? So biology is not as much of a memorization science here as it is in other campuses. You certainly do have to memorize something, but we all know that if you need to get information about the different phyla, for example, that exist among different species, you can go look it up. But you need to know how that is put in the context of the framework of how everything is organized. And so the biology program here has a lot of integration of chemistry, mathematics, and physics integrated into biology. Because biology is much more of a quantitative science than it used to be. And rather than just having courses like zoology and botany where you're memorizing those particular aspects of biology, where the faculty have designed programs that are much more integrated. So there are 5 emphasis tracks. Put forth molecular and cell biology, human biology, ecology and evolutionary biology, developmental biology, and then micro and immunology are together. So, sample plan. I'll just run through a few sample plans. You can see in yellow same courses that you need to take for the other majors. The general ed courses are shown in blue. The biology major takes 2 semesters of intro biology with lab. We have a lot of labs in our courses, a lot of hands-on types of learning experiences. Molecular biology of the cell, molecular machinery of life, and so forth. They take physics, they take chemistry, and then if a student is focusing on molecular and cell biology, you'll see that there'll be other types of courses that, like MCV, elective course, evolution, and so forth, that the students will take. Let's see. Okay, so let me move on. This is human biology emphasis. Very similar, except that on the upper division courses, you will take more courses in the area of basic biology with cognitive science and psychology. This is a very popular emphasis track, as is MCV, for students interested in health professional careers. Ecology and evolutionary biology. Again, the first 2 years look the same. And you can take the biology intro courses and think, well, you know, I wanted to be a developmental biology emphasis, but you could get really turned on by what's going on in the area of ecology, of conservation biology. And you can very easily switch without any loss in time. The work in a bio major leads you to research or in academia or research in companies. It can lead you to health professional degrees, medicine, dentistry, veterinary medicine, nursing, pharmacy, and other health-related fields. You can go to the webpage of the School of Natural Sciences and you can see the success that our students have had already in getting into top-notch health professional schools in the area of medicine, veterinary medicine, public health, pharmacy, etc. So our students are being very successful in competing for these limited number of spots in health professional schools. Bio major can lead you to careers in biotechnology and pharmaceutical industries, conservation management. Increasingly, knowledge of biology is important for law, for policy, for management, for business. So it can lead you in many different places, and of course, teaching. A couple of highlights of some of our faculty. Monica Medina is an assistant prof. She works on, her research is in the area of coral reefs and looking at the relationship between coral bleaching, health of coral reefs, and symbiosis with other organisms. She recently received a presidential award for her research efforts, a very prestigious award that very few people have achieved, and two faculty from UC Merced have received that in the past few years. Jen Manilai works in the area of stem cell biology, particularly trying to understand how stem cells specialize into becoming immune cells, particularly along the lymphoid lineages. And both Monica and Jen have a very large cadre of undergrad students in their research labs. Some who even come in as freshmen who are well prepared and who are contributing to their research. Stem cell biology as a research program is very strong here at UCM. We have 8 faculty in this area across the schools of natural science and engineering. Chemical sciences also a major that is very fundamental to preparing you for lots of different opportunities. We can have a pure chemistry track, or we can also have emphasis areas in biological chemistry, environmental chemistry, and materials chemistry. Again, just a sample plan. Again, I'm not going through the details, but showing you that the first couple of years is very similar. You can start out as a biology major, and you have had some start out as biology majors and really like chemistry or biochemistry or chemical biology, and then you decide that's where they want to go. Oftentimes, it's a faculty member that really is able to excite your interest in a particular area of a discipline that encourage you to consider other options. Chem major can lead you to careers in industry, government, forensic chemistry and crime labs, commercial fields such as patent law and scientific writing. So if you're interested in science as an undergrad major, but you're also interested in policy or economics, you can combine those and take courses that are going to help prepare you to go into these kinds of fields. High school science teaching, research at colleges or universities, and chemistry can prepare you for careers in health sciences and health professions as well. Many of you might think you need to have a biology degree to be, well prepared for a career in health professions. That's not true at all. You can go to medical school with a chemistry degree, or a physics degree, or even a math degree, as long as you take some of the life science courses so you can do well on your impact, which is your pre-medical exam. Some of the areas of chemistry research that are here at UC Merced are shown on this slide. Professors Meyer and Tsao work on rational drug design for a number of different diseases. Professors Kelly and Menke work on materials chemistry for solar energy, particularly for photovoltaics. Professors Ann Kelly and Matt Meyer also have research programs in the fundamentals of chemistry, reaction dynamics. And Professor Tao Ye works on applying chemistry for bioanalysis in tissues. Professor Tao Ye is shown here, and he is developing, as it's written here, he's developing different types of strategies and approaches to assemble molecules at the nanoscale level to make these molecular motors that can pull molecules along in a particular path. And he has several undergrads in his lab as well. Professor Menke just arrived last year. He's very interested in applying chemistry principles to solar energy, create chemical fuels for solar energy. The second to last major I'll talk about is Earth System Science. This is a very interdisciplinary major. It integrates the study of fundamental chemical, physical, and biological processes that are shaping our environment, that are guiding our environment. And the core courses are a mixture of courses in chemistry, physics, calculus, as well as biology, hydrology, ecology, and earth sciences. This is just a sample plan for Earth System Science. Again, same courses that you take as you would be a biology major very early on, and then as you decide you're going to specialize into Earth systems in semester 5, you might take quantum chemistry and spectroscopy. Semester 6, you take chemical thermodynamics and kinetics, physical instrumentation labs in semester 8, and so forth. The work in Earth System Science major leads you, like many of the science majors, many places. It leads you to graduate school, to jobs in industry or government, increasingly in the health of the environment and the management and sustainability of our environment are coming to the forefront of in a lot of areas, and students who are well prepared in understanding the processes that comprise or define the Earth system will have many opportunities for jobs in a number of different areas. Environmental research, conservation, management, sustainable agricultural sciences, and of course careers in law, policy, and management. So what I'm trying to do is to encourage you to think that a career in science, no matter what the degree, opens up many different opportunities, perhaps in areas that you hadn't even thought about, such as policy or management.